So in this video, we're going to do examples 9 through 11. So in example 9, we're supposed to use the fundamental identities to simplify the expression. So in this one, what I'm going to do is I notice that I've got 1 minus cosine squared. I know, and I'd like to make that simpler if I can. I know that this piece here has a cosine squared and a 1. I'm going to try to subtract the cosine to the other side. So I get sine squared theta equals 1 minus cosine squared theta. And you'll notice that this and this are the same. So that means I can substitute in sine squared for it. So I get cosecant squared x times sine squared x. Now, I'm wondering if I can do anything with the cosecant. I know the cosecant is the reciprocal of sine. So I've got 1 over sine squared x times sine squared x. And then you'll notice that these guys cancel. And so I end up with just a 1, and they can't really get simpler than 1. In examples 10 and 11, we're going to factor and then use the fundamental identities to simplify. So we can factor just like we do factoring with variables. So let's just remind ourselves really quick. If I had x, y plus x, okay, or even if I had x squared, y squared plus x, notice how I have an x squared in both terms. I could take out a greatest common factor of x, and I'd be left with y squared plus 1. Okay, so let's go ahead and look at this one here. Do we see how we have a secant squared in both of those? I'm going to take out a greatest common factor of secant squared, and I will be left with tangent squared x plus 1. Well, I notice that tangent squared x plus 1 is really the same as that, which means I get to substitute in secant squared. So I have secant squared x times secant squared x, which is really secant to the 4th x. Let's look at another different type of factoring. So let's say I have x to the 4th minus y to the 4th. That would be what we call a difference of squares factoring, because I've got even exponents, which makes them square terms. You probably remember seeing something like x squared minus 4. Same idea. So remember, we take the square root of the first one, which means we divide by 2. Square root of the second one, which means, again, we divide the exponent by 2, make 1 a plus, 1 a minus. Okay, we're going to apply that same concept here. So I've got cosecant squared x in the front. I'm going to erase this mess here because it's in my way. And then in the back, I've got the square root of cotangent would be cotangent squared x. And I'm going to make 1 a plus and 1 a minus. So now that I've got that, I'm kind of looking to see, is there anything else I can do to simplify that and make it nicer? I notice that cosecant squared is equal to 1 plus cotangent squared. I don't know that I can do anything much in this one, but let's try putting that in this one right here and see what happens. So if I put in 1 plus cotangent squared x minus cotangent squared x, I notice that these guys cancel out and go away, and this guy just stays the same the way it is. And then it's just times 1. So my final answer would be cosecant squared x plus cotangent squared x.